Thank you. So I work at HP. In my role there, I work directly with the OpenStack project on the infrastructure team with a couple other people in the room here. And part of what we do is all the systems administration that we do in OpenStack is done in the open. All of our config files are available and everything. And so I thought I'd take some time to talk about how we make that work. So I've been involved in a lot of open source projects over the years. And there are all kinds of ways that open source projects manage their infrastructure. I've seen some where it's just some guy who has a server, and if you want something on it, you have to email him and send an attachment or something. Indeed, I'm one of those people. For the Ubuntu community, I manage a bunch of servers that people send things to me. I give them shell accounts if they need to run something. But there's no real process for me to interact with them. No one has seen my config files. I just sort of put things up when people ask me to. Also in Ubuntu, Canonical runs all of the official sort of community resources and websites and everything. And if you find a problem on one of their sites or one of their things, or if the wiki is slow, you have to email Canonical, send a ticket in through Request Tracker. And in this situation, and in the situation that I have with Ubuntu, it's pretty much requests are just submitted in this very simple way, and then the priority of whether your fix gets changed is related to how busy the team is and what sort of priority level they set to that. So if someone wants me to spin up a few scripts, I'm at LCA this week, so it's going to take me a couple of days to get back to you. So in OpenStack, we sort of were wondering if there was a better way to do this. Instead of bothering the infrastructure team to go and do everything, what if you made the entire infrastructure open source so that anyone can submit patches to the actual infrastructure as well? So the infrastructure team in OpenStack runs the continuous integration system that all the developers use to submit their code. And then there's a code review system. And then we manage all of the servers that the project uses, the wiki, all the mailing lists, and all kinds of other things that the project members use, IRC bots. And everything we have is in a Git repository, which I can show you. So our infrastructure has lots of public projects. And then we have all of our Puppet configs. All of our Puppet modules and everything that we do to set up servers is in there. And this is just at git.openstack.org, so anyone can go to this URL and read everything that we've done. And then we run the infrastructure project just like any other project in OpenStack. Anyone can submit changes, and then they're peer reviewed, and then there are a few core reviewers that can actually do a bit more review and approve the changes. So I want to talk a little bit about how we make this work and how our continuous integration system in OpenStack works in general. OpenStack itself is made up of a lot of individual projects. So it was relatively simple for us to put infrastructure into that. We're just another project. But when it comes to OpenStack, it's a lot of small projects that come together to build a big project that we call OpenStack. So we have a lot of integration testing that needs to be done. So when someone commits a change to the computing module, it doesn't break a storage module for some reason. So with every code commit to OpenStack itself, we're running it through 40 minutes of testing to make sure it's all working well. We also decided that since we've got dozens of companies and over 1,000 developers working on this, we wanted to have pretty strict coding standards. So we have syntax checkers on code for things that people submit to the project. And that goes for our systems administration as well, which I'll talk about. And also testing has to be completely automated. OpenStack has hundreds of commits a day, and again, thousands of developers, lots of companies. So we don't want to have any sort of testing that is not automated. It's just not scalable at all. So to build all of this, the OpenStack Infrastructure Team uses a few open source tools, all open source tools. We use Launchpad at the moment for authentication of users, for bug tracking and for blueprints, which is how we sort of plan out what we're working on in the development cycle. We use Git, of course, and then we use Garrett, which is a front end for code review. It's very nice. We use Zool, which Jim's giving a talk on Friday. That's sort of handles how commits come in and passes them along to Jenkins, and then determines how they're queued up for merging once they're approved. It's much more complicated, that's why there's a whole talk. We've then got Gearman, which is something that passes all the jobs from Zool to Jenkins or whatever test thing that we have running. We use Jenkins at the moment. We also have a couple of projects that were written by the infrastructure team. Jenkins Job Builder, that makes it easier for people to write Jenkins config files because everyone hates XML. So it's YAML files that are then built into the Jenkins XML format. And then we have DevStack Gate, which handles building all of our DevStack stuff. DevStack is the development infrastructure for the tool that developers use to spin up a simple version of OpenStack to do development against. And that's also what we put all of our testing against when we put it through our integration, our system. And then we have Node Pool, which pretty much manages a fleet of virtual machines that are always available for testing. So whenever you need to run a Python, well, that's not on there. When you need to run a DevStack test, you just go out and find a virtual machine in the pool, and Node Pool will tell Jenkins what that is, and then when the test is done, it'll destroy it and then create new ones. And then every day we refresh that image, so it's a new image every day, and then when you actually bring the stuff into it, it doesn't update. So whatever's updated throughout the day comes into there. And again, these is open source, and the ones that have stars next to them are ones that were started by the OpenStack Infrastructure Team. Interestingly, some of them have sort of grown beyond us. Jenkins Job Builder has core reviewers who have nothing to do with OpenStack. They just use Jenkins Job Builder in their own company or organization. And this is a pretty picture of what I just explained because it's complicated. So you have a little guy over here. This is your computer. You send it to code review, and it goes through all this stuff. It comes back and finally gets merged into the Git repository and then gets mirrored over to GitHub and Git.OpenStack. And this is much more complicated than you need for most projects. If you were doing like systems administration where you want to do code review, you probably wouldn't need Zool and Gearman and all this stuff. There is actually a connector that goes from Garrett directly to Jenkins, but this is how we do it in OpenStack. So what we use this thing for, we use it for all, of course, the core OpenStack projects. If you're an OpenStack project, you have to go through this whole system. We also have another repository called StackForge, and that's for projects that are either in incubation in OpenStack, they're not really part of core yet, or they're just projects that are related to OpenStack, but they're not really sort of core stuff. They're just things that people are working on and want to use our review system, and they're related to OpenStack. The documentation team also uses the system, and then we use the system for systems administration. And this is what we do. This was put together at a sprint back in June. I think Clark wrote it, like all the things that we do up on some papers. If you're a sysadmin, this probably looks pretty familiar. Like you have all these servers. They're all connected in crazy places and you forget what you have. But this is actually what we have. This is a list. So of course, we run the continuous integration systems. We've got Cacti and Logstash, and Clark's doing an Elasticsearch talk on Friday, which will be awesome. Then we run IRC bots and Etherpads. So all of this stuff is stuff that we manage. And everything we do, as I said, is in public. So anyone on the internet can look at our changes. And I can show you. I can't actually see my screen on my laptop. So. So this is Garrett. Let me see if I can find one. So this is the view you will get in Garrett if you are not logged in. So I'm not logged in at the moment. Anyone can see any of the OpenStack changes publicly on the internet. How do I search for just config ones?
65405.
65405. All right, so this is something that we're currently working on as of like this morning. Well, Jeremy's working on it. We're not because we're here. So this is sort of what the code review screen looks like. Now we're working on Zool, and Zool is part of our continuous integration system. So we do all of our code reviews and development on the tool that we're actually using to, Zool is part of this. And we're using Zool to check this as well, which is all kinds of fun sometimes. So you've got sort of all the Git information over here, and then the commit message. And then you have patch sets. This one's boring because it has no comments. So in this one, he's actually modifying some Puppet files. So you'll see our manifest site.pp, and that's where we list of all of our sites. And again, I'm not logged in. This is just public on the internet. So it's got tells you when it gives you a diff. So in this case, he's adding a single variable to the Puppet file, and then pulling the data from Hyra. Oops. And then this one, we're using parameterized classes. So he's adding the variable to here too, so you can see it's in green. And doing some other things, right, so that he's creating a SSH file and adding the content there. So this is normal sysadmin stuff, right? Like you do this all the time, but we do it in code review. So this change, Jim will comment on it, I'm sure. No, he'll just approve it. We'll all review it and we'll take a look. You can put inline comments in Garrett and other things. So it's a pretty cool system. So I showed you that anyone can look at this. I wasn't logged in. Also, anyone can sign up for a code review account. I think we still don't require people to sign the contributor license agreement to do code reviews. So you can just sign up for an account, which is an open thing to do, and then start doing code reviews. So you can look through all of our Puppet changes that we have pending if you want to fix something or if you're interested in what we're up to. And then you can write reviews just as a random person on the internet. I mentioned we have this whole continuous integration system, right? Like that does a bunch of checks and we use Jenkins. So we decided to use that for ourselves too. So we run a bunch of Python syntax checks against our own code to make sure they're also within standards of OpenStack. We run some Puppet checks so that we know that Puppet is not going to fall over, hopefully, when we commit the change. And that's been super useful. We also have XML sort of checkers, and we recently, I don't know if this has been committed yet, but we have a one that checks for alphabetized listing of projects, because that was really hard to manage manually. So I think Fungi maybe wrote a script for it or something. And Sergey? Okay, yeah. Someone wrote a script to make sure that the file stays alphabetized. So if you commit a change to that file and it's not in alphabetical order, you'll get Jenkins yelling at you and saying, no, no, no. So that's exciting. So we are automating as much of this as we can. But I think the most valuable thing that comes out of all of this code review stuff is really the peer review. So it's great to have syntax checking. It's great to have all these automated tests. But the core of what makes this really valuable is having peer review and creating a culture where you're reviewing each other's changes and collaboratively solving problems. At my old job, it was a small little tech services provider. We were hosting sites for museums and small companies and other things. And it was sort of, we had our own infrastructure, but when something went wrong, like it was like, okay, you go put out the fire over there and I'll put out the one over here. And while we did get together to talk about solutions and things, it wasn't really a collaborative environment in the way that what we do is. And anyone can ask questions if they have any, whenever. But with this, so instead of me going off and fixing something, I go off and fix something, and then instead of committing it directly, it goes through a process where we can discuss what the change is. And that's really helpful for us because we're a distributed team. We work for multiple different companies on the infrastructure for OpenStack, and none of us really, well, Clark works in an office, but he's like the only one. We all work at separate homes. We've got people all over the US at the moment, hopefully expanding that. So we see each other at LCA apparently. But we're trying to do this collaborative environment on the internet. And then it's also a really good infrastructure for developing new solutions. So when we have something that we're trying to work on, we can toss it up in the code review system, and that gives us a really comfortable place to discuss what the changes are. And then we have this work in progress option, so you're not really reviewing it for merging yet. You're telling the rest of the teammates that it's a work in progress, and to commit to comment accordingly. And again, yeah, particularly for a distributed team, it gives us a really nice way to do it. We're not dumping things in paste bins and saying like, hey, look at this config file. We're actually committing the code and getting up to a level where it's going to be ready to be submitted pretty soon. This also means that we don't really have a special process for giving you commit access. I was talking to a sysadmin friend who was telling me about like the process of getting commit access to his systems administration stuff in his office, and how it's like this horrible hazing process. like you do a bunch of things, and people are like saying, okay, you're good enough, but let me commit that for you, and then after a while, you have to like go in front of the board, and they're like going to judge how well you are and whether you should have commit access to the repository or not. But for us, we don't really have that. We have a few people who have core access, so they can approve anything. They can actually submit their code and approve it themselves. But there's not really a way to skip going through that process. If someone does that and they're doing something bad, we'll see it. It's like in the code review system. It's usually because we're all at LCA and someone needs to fix something that broke. that happens where someone approves their own change. But typically, normal people, most of us, don't have that sort of access to it. So we don't really have a process for commit access because everyone and no one has commit access. I was going to say it trains us sort of to be collaborative by default. Of course, in my old job and other systems administration stuff I've done, I've sort of worked on my own, and I talked to my colleagues when we were planning things. But for this, like every single time we make a one-line change to a config file, it has to go through code review. It may seem like that's a lot of work and that it's too much, but it allows us sort of to be all on the same page. And we're so used to working with each other on anything that when we come to something that we can't actually fix through code review, like if we're doing some sort of major upgrade or other thing that we can't actually fix through this system, we're already all on the same page. We're used to working together, and we sort of all collaborate in an Etherpad and on IRC to work out a migration plan. And we work really well together, I think. So once we've gone through all that review and collaborative happiness stuff, oh, sure, question.
Did you start that from day one, or did you put that process in place when most of the work was already done, so all the difficult stuff was already solved, and then you are just adjusting stuff?
Right, so the question is, did we do this from day one, or is this something that came after a lot of the stuff had been in place. So it certainly wasn't on day one. Initially, it was sort of a standard sysadmin infrastructure project that open source projects do. Like, they stand it up, and then if you need something changed, you talk to the infrastructure team. I don't really know the timing on it. I mean, it was definitely more than a year and a half ago that we switched to doing the code review. But I think it was our leader at the time, Monty. You're the leader now. he was like, patches welcome, and so it was all open sourced. But I don't really know how much stuff we had in there before we open sourced it all.
We started it very, very early.
So it was pretty early then.
Yeah. I think by the time we had, we were fully managing servers in Puppet in the public Git repo. We only had a technical debt of a handful of servers that weren't managed that way.
Yeah.
One of them is Jenkins, which is still not fully managed.
Yeah, Jenkins still not fully managed, and Garrett's got a few niggly bits. Yeah. Almost there. When we have some free time. So once it goes through all that code review and everything, the change gets checked in. So Garrett goes through the whole thing of testing the change and everything and sends it back. And then Garrett will actually commit to the repository. So Garrett is the only one who actually has commit access. Only robots, no people. And then we're running Puppet. Not because we love Puppet, just because that was what someone could install one day. I'm sure Chef is lovely. So the Puppet master gets updated and applies the change. And then if it's an application that we're using, one of the ones we're developing, something like probably Jenkins Job Builder or other things, we have a Puppet thing that routinely checks the repository and pulls in new versions as we need them. And so I've gone through all of this, and I wonder, does this actually work? There are a few things that we've done to make it a bit easier and have it actually work. We run cacti so that we can keep an eye on server usage. And again, this is public. Don't go to it. It's really slow. But we have cacti graphs of all of our servers, and this is really valuable. So I don't have login to the servers, but if I wanted to add a program or something to one of our servers, and I wasn't sure which one to add it to, I can go to cacti and say all right, is our static.openstack.org server overloaded? Do I think I can run this cron job every 15 minutes and not have problems? Does it have enough space in the file system for me to dump all my web files or whatever I'm creating with my program? And that allows me to do this without being like, hey, Clark, what server should I put this on? I can sort of look on my own and make an educated guess. And if I really don't want to talk to anyone, I can just toss up a code review with the change, and then they'll comment on it and say, no, don't put it on that server. Move it to another one. So cacti allows not only the people who have logins, but anyone who wants to figure out what the server load is. I say we have a Puppet dashboard, but it's kind of broken at the moment. But let's pretend we still have it, because we're going to bring it back. Or Puppet board, or some sort of visualization that shows Puppet changes coming in. So we used to have this Puppet dashboard, and you'd be able to look on all of the servers that we run Puppet on, which is everything. And you can see your changes being applied or not, and you can see the error logs or the success logs. So that was really good when we submit a change and we want to see whether it got picked up or not, whether it broke, which happens all the time for my changes. But then I can just watch Puppet dashboard and I can say, okay, did my change break? I don't need to ask someone to look at log files for me. I can just look at the dashboard and I can say, oh, that broke, and then write my new change to fix whatever broke. And then we have really good documentation for most things that we work on at ci.openstack.org. And that's here. So this, oh, sure, yeah, question.
Could you spin up a series of test servers or anything to account for changes to the system and stuff?
The
Tests around it?
So the question is, do we spin up test servers before putting things into production? Not really. Not in a formal way. Presumably, when you're doing the code review, someone who's reviewing the code probably should test it. Then we also have instructions here in our lovely documentation for specifically making a change in Puppet. So this is lots of words. They're all very important for understanding our Puppet infrastructure. But then we have specific instructions for if you wanted to test a change we're applying to Puppet, how to grab our Puppet configuration, how to create sort of a local file that has your change in it and then applying that change. So it's not too hard to test a change on your own. And then people doing the code review should probably test your change as well.
Where's the source for that page?
Where's the source for that page? The source for that page is in Git. So if you go to...
It's like saying the source for that page is on the internet.
Yes, so it's in our config directory under doc.
Because you're recommending that people check out stuff as root.
Yes, I noticed the first line of that was a sudo su to root. You should prefix every command with sudo. So there's a history.
I think we did that and then we got sick of doing that. But patch is welcome.
So actually, Puppet behaves differently if you run it with sudo versus from a root shell. So part of those instructions are you have a dedicated virtual machine. Those are not instructions for what to do on your local workstation. They're instructions for you have a virtual machine that you want to annihilate and turn into, say, an Etherpad server. And so it's going to have to do lots of things as root, and it actually does them incorrectly if you do it through sudo.
Right, so we actually do need to run things as root, yeah. Yeah, and we work on OpenStack, so it turns out we have a lot of virtual machines around. So mostly when we're doing tests, we all have piles of virtual machines, and so we do them on throwaway virtual machines that we get rid of after we test the code.
Almost certainly a doc bug if the docs don't say what I just said.
Yes, if the docs don't say what you just said, that's a bug. We should fix that if it doesn't say that. Anyway, these are all our RST files. We write it in restructured text because we're Python people, and that's where all our documentation is. So if we find more bugs. So yeah, I love our documentation, and I work on it often. So yes, you can definitely manage all this stuff through commits. Now there are some limitations to this. You can't actually do everything through code review system and just commits to Git and Puppet stuff. Sometimes you need to log into a server. There's one thing that happens sometimes is like someone signs up for an account in Garrett and it gets a little messed up in MySQL or something needs to be changed. So someone will need to log into a server and get into MySQL shell and fix whatever's broken. So there are still times when you need to log into a server. For difficult migrations and upgrades, you still need to write out a migration plan or an upgrade plan, and then you typically have to shut down whatever services you're running or fail over to something. We do actually have a development version of Garrett running, because Garrett's our code review system, and it's the core of what everyone uses. So we often do test changes on that. So we're in the process actually of upgrading Garrett. And so our Garrett development servers got the new version, and now we're working out the bugs and fixing things in that. But that's not really something, so we do manage that server through the code review system, but there are things you need to log into the server for. And then, of course, passwords have to be privately managed. Other things like private SSH keys, and it turns out email addresses have to be put in Hira, because I hear before my time, there was a time when we put our email addresses in all of the Puppet config files in public, because whatever, our email addresses are public, right? Well, it turns out people would download everything, and then we'd start getting emails from other people's infrastructures, and that's not so nice. I mean, it was funny. It maybe added the SSH keys. No, I'm just kidding.
I checked its firewall.
Oh, it's fine. Yeah, so passwords, and there's other sensitive data. I mean, we're an open source project, so we don't care if all of our host names are out there, but some people may want to put their host names in Hira and not let that be out there. So those are privately managed. So that's pretty much all I had. I'm sort of wanted to show this off because I think it's pretty revolutionary in how we do for an open source project. Now that I go back to how I'm managing my Ubuntu servers and how I have to submit a ticket with Canonical, it seems like they're doing it wrong now. I was talking to some people about the Ubuntu wiki, and it runs moin moin, which it turns out wasn't really meant to scale to the massive thing that is the Ubuntu wiki. So everyone says, oh, we should switch to MediaWiki. And I'm like, but then we have to submit a ticket. You know, if we had a system like this, like we could just write all the configs ourselves and do the migration and put it together. Yep.
So when are you going to submit a ticket to Canonical saying, you should run Garrett?
When am I going to submit a ticket to Canonical? Say we should run Garrett. Yeah. Never. They should. I just need to talk to them. Other question? How do we manage our Hira? That's a very good question. So we have 4 people on the team who are root admins. So they have root on they have SSH keys that have root on all the machines. And so they are the ones who manage the Hira configuration. So I don't know exactly how they manage it, but they just type and fix things. But they're the ones who have access to that on the Puppet Master. So what actually happens is if I need a private SSH key or something, what I'll do is I'll say, hey, Clark, I need a private SSH key. Usually in review, I'll leave a comment in the code review and say, hey, this needs to be created. And then Clark will give me a variable to use in Puppet and say, I added your SSH key in Hira, here's how to reference it. But there is a core team that handles all of that. So I pretty much covered it. Yeah, my favorite is priority is determined by the submitter. If someone wants to do something on the infrastructure team that we have, they don't need to wait around they have to wait around for us to review it and approve it, but they don't need to wait around for us to come up with a solution to fix something. If something really needs to be done, someone can come along and do it for us. The guy who manages our wiki doesn't work, he doesn't work full-time with us. It's just something he does because he manages a lot of wikis. And so we have a lot of part-time contributors who sort of come by and work on one thing. So that is why it's great. Yeah.
Can you share any information about sizing? So the size of the teams, the number of servers, the SQL virtuals that you have?
Yeah, so the size of the team, we've got 5 of us working full-time on it? 6? 6 people working full-time, and then we've got people working, as I said, people who just come by, drive by, and fix a few things, or are working part-time on it. As far as the number of servers, so if you don't count our entire continuous integration system, which is hundreds of virtual machines that we spin up and manage with Nodepool, the number of servers we have that actually, long-lived servers that hang around and run cacti and other things, we can look, we could look at cacti. All right, so let's see, we've got our Puppet Master. We've got Eavesdrop, which is the thing our IRC bots run on, Elasticsearch servers, a bunch of Git servers. We have a Graphite server, Jenkins. We have 5 Jenkins servers as of yesterday. We used to have 3. And then the mailing list server we run. We have lots of Logstash servers. So that's all of the servers that we run that we keep up all day long.
The graph that I'm not going to swear by says somewhere around 35-ish, maybe?
Okay, so Jim says somewhere around 35 of servers that we keep up all the time. And then the ones that Nodepool manages, I think
is
another 400 or so, yeah. So those are the machines that we run all the tests on that are just sort of just out there on the cloud. But these are the ones, these are the puppies. Those are the cattle.
I noticed that I had a look at some of your Puppet modules, and you don't have any of those modules
So we had to fork a few of them just because of some other things. We actually have a script. So in our install module script, we do pull in some things from other people's things, but it's not a lot. So yeah, we that's something I'd really like to see us do a better job of, because it turns out we fork modules and then we keep our own versions of them, and then we ended up with an Apache module that's really old and has weird, like, there was a newer one that we couldn't use, so we didn't upgrade it. And I think we have a bug out for upgrading all of our modules to ones that are more current and seeing whether we can bring ours back to the upstream version. Because yeah, that's not great. But we do write a fair amount of our own, and when we write our own, we try really hard to make sure that anyone can use them. So we have. So we have all of these, which in theory should all be very generic. So anyone can grab one of these Puppet modules and use it on their own. And then we put all of our custom configurations in the OpenStack project module, in theory. It turns out we have .org hard-coded in some places. So when I was setting up a test instance at home where I have a .com on my LAN, that was not so great. So I submitted some patches to fix some of those that I was setting up. But I don't know why we did that. But yeah, so in here we'll have all our files and stuff that are custom for us, like the OpenStack logos and all kinds of things that are custom for us. Yep, question?
From when you guys originally opened up doing gigs and stuff like that, how much has community involvement gone up?
So the question is, since we open sourced all this, how much has community involvement gone up? I don't know, actually, because I wasn't around then. But we definitely have a lot more interest in people contributing things, just because it's available there and it's all out in the open and they can contribute. We've also discovered there are some people who just like to complain and won't actually fix things. Like, what? The source is there, you can fix it. And they're like, bah. But we do get a lot of, we do get community members who just come by and do drive-by patches, and it's really nice. It's good to see those.
Particularly after we had the boot camp, a lot of we had an event, like a day-long event, where sort of people become accustomed to the specifics of this. And
Yeah.
right after that, we started to get really good patches from other folks in the community.
So Jim was saying we had a boot camp last year. We had like 20 people come out to New York City, and we all sort of got together and told them how to told them about our infrastructure and then how to make changes to our infrastructure. So that was really helpful in getting people to contribute, because now they knew how. Yep, question?
Coming back to the server stuff, what you have shown on the dashboard is a lot of virtual machines, in fact, in which you run the software. But how do you manage the hardware part? So if there is a disk failure, do you get a warning somewhere? I guess you are working for the same company as I, so are you using the specific tools that we have to monitor the servers?
So the question is, how do we handle our hardware servers? We don't have any. Everything is virtual. We never want to have any. It's someone else's job to replace disks. Yeah, so we use all cloud servers. We are working with a couple of teams to do some bare metal testing on some of the OpenStack stuff. But in those cases as well, part of the agreement in the clouds that are provided to us, the hardware that's provided to us, is that we won't have to handle disks. We want a working rack, and someone else. We have to have someone who's on call, and we have to have someone who's going to go fix disk for us. Fortunately, OpenStack is, it handles disk failures and things if you're got a decent infrastructure. So, yeah.
Apart from this failure, if you want to do some optimization, performance measurement at the hardware level to see when you have congestion somewhere or whatever, any tooling?
Any tooling for hardware stuff? I honestly don't know. Yeah, I haven't done much with that. Certainly not here, just because we really hate hardware. Any more questions? All right, cool. Thank you.